The sun. It's a giant ball of glowing gas. It's incredibly hot. The sun is the center of our solar system. Every morning the sun rises. It brings light and warmth to our planet. Without the sun, life on Earth would not be possible. The sun is about 109 times wider than Earth. You could fit over 1 million Earths inside the sun. That's how massive it is. The sun is about 93 million miles away from Earth, yet its light and heat reach us every day. That's the power of the sun. The sun wasn't always there. It formed billions of years ago. A giant cloud of gas and dust collapsed in on itself. This is called a nebula. As the cloud collapsed, it spun faster and faster. This spinning motion flattened the cloud into a disk shape. The center of the disk got hotter and denser. Eventually, the temperature and pressure at the center became so intense that nuclear fusion began. This is when lighter elements combined to form heavier elements, releasing a tremendous amount of energy in the process. This marked the birth of our sun. The leftover gas and dust in the disk eventually clumped together to form the planets and other objects in our solar system. The sun is like an onion with different layers. The innermost layer is the core. This is where nuclear fusion takes place. Temperatures here reach a scorching 27 million degrees Fahrenheit. Surrounding the core is the radiative zone. Here, energy from the core travels outward in the form of radiation. It takes hundreds of thousands of years for energy to travel through this dense region. Next comes the convective zone. Here, energy is transported through convection, similar to a boiling pot of water. Hot plasma rises to the surface, cools, and then sinks back down, creating a churning effect. The sun's surface is called the photosphere. This is the layer we see from Earth. It's covered in granules, which are the tops of convection cells. The sun's energy comes from nuclear fusion. In the sun's core, hydrogen atoms are under immense pressure. They are squeezed together so tightly that they fuse to form helium. This fusion process releases a tremendous amount of energy. It's like billions of hydrogen bombs exploding every second. This energy travels outward from the sun's core. It eventually escapes into space as light and heat. The sun has been shining for billions of years. It has enough fuel to keep shining for billions more. Section 5. The sun's gravity, holding the solar system together. The sun's gravity is what keeps all the planets in orbit. It's like, well, an invisible string holding everything together. The more massive an object, the stronger its gravity. The sun is incredibly massive, so it has a very strong gravitational pull. This pull keeps the planets from flying off into space. It also causes them to orbit the sun in a specific path. The sun's gravity also affects other objects in the solar system, like asteroids and comets. Section 6. Light and heat. The sun's energy reaching Earth. The sun emits light and heat in all directions. Only a tiny fraction of this energy reaches Earth, but it's enough to sustain life. Sunlight takes about 8 minutes to travel from the sun to Earth. When it arrives, it warms our planet and drives our weather patterns. Sunlight also provides the energy that plants need for photosynthesis. This is the process by which plants convert sunlight into chemical energy. Without sunlight, there would be no plants. And without plants, there would be no animals, including humans. Section 7. The sun's influence, seasons and weather patterns. The Earth is tilted on its axis. As it orbits the sun, different parts of the planet receive varying amounts of sunlight throughout the year. This tilt is what causes the seasons. When the northern hemisphere is tilted towards the sun, it experiences summer. When it's tilted away, it experiences winter. The sun's energy also drives our weather patterns. When sunlight warms the Earth's surface, it causes air to rise. This creates areas of low pressure. Cooler air rushes in to fill the void, creating wind. The sun's energy also powers the water cycle, which leads to rain, snow, and other forms of precipitation. Section 8. Life-giving star. The sun's role in supporting life. The sun is essential for life on Earth. Without it, our planet would be a frozen, lifeless rock. The sun provides the energy that drives photosynthesis, the process by which plants convert sunlight into chemical energy. This energy is then passed on to animals that eat plants and so on up the food chain. The sun's warmth also keeps Earth's temperature within a range that can support life. Without the sun, Earth would be too cold for liquid water to exist. Our oceans would freeze over, and life as we know it would not be possible. The sun's energy also plays a vital role in the Earth's atmosphere, driving the water cycle and creating weather patterns that distribute heat and moisture around the planet. Section 9, conclusion, the sun's enduring importance. The sun is a powerful force in our solar system. It is the source of our light and warmth. It dictates our seasons and weather patterns, and it is the ultimate source of energy for all life on Earth. As we continue to learn more about the sun, we gain a greater appreciation for its complexity and its importance to our existence. The sun is a constant reminder of the interconnectedness of our universe and the delicate balance that sustains life on our planet. It is a star that has captivated humanity for millennia, inspiring myths, scientific discoveries, and a sense of wonder that continues to this day. As we look to the future, understanding and appreciating the sun will be crucial as we strive to harness its power sustainably and ensure the continued flourishing of life on our planet.